Okay, good evening, ladies and gentlemen, and welcome to this Monday evening edition of our live coaching session where we are going to decode a very important uh, tool of Lean Six Sigma, which is control chart. Okay, control chart is a very important tool. See, the DMAC framework actually is nothing but it is a garland. I always give this example. It's a garland of all these amazing tools, okay, which are put in the sequence of this framework so that you can put the problem in the beginning and you get the solution at the end of the end of this entire DMAC framework. So each and every phase contains the tools. Now these tools were already existing. Okay, they were already existing before the Lean Six Sigma start. Okay, so they were existing individually, but what Bill Smith and Professor Michael Harry has done, the fathers of this model, the DMAC framework, that they have put this entire set of tools in the sequence, and the control charts is one of the very important tool which we are going to learn. That also is now control chart. The father of the control chart is the person who invented control chart. Anybody knows the name who is father of control chart? Just give me the name in the chat if you are aware of it. Yeah, just put it in the chat box if you are aware of who has invented control chart. Is it on? If yes, just give me just a second. Okay. Yeah, can you just type something? Is the chat active? Yeah. Walter Shewart, fantastic, amazing, super. It's Shewart. It is also called as Shewart charts. Control charts are also called as Shewart charts because they are invented by Walter Shewart. Now, Walter Shewart was, he was a statistician. Okay, and he did lot of experiments around the data, and he concluded something very interesting. What he concluded, if we put the process data is also called as voice of process, VOP. VOP is nothing but data. Okay, let's say, for example, let's say you are into sales department, and daily sales, if you put that daily sales data, that is nothing but voice of process. The sales is a process, and from that process, whatever data which is getting generated is called as voice of process. Like we have voice of customer, right? What customer gives us the feedback, complaints, requirements, that is called voice of customer. Similarly, how the data speaks is called voice of process. Now, when we plot this data, for example, sales data or for production data, okay, for example, let's say I'm plotting every day sales data or production data, or and if I connect this, understand this, okay, against the time, so I can see the trends moving up and moving down, right, like this. Now this graph is called as what? Type in the chat box. This graph is called as what? Everybody type in the chat box. Fantastic. It is called time series or a run chart. Absolutely right. Both are the same thing. Either you can call it as time series plot or a run chart. Time series. Now the name itself indicates it is against the time. So time series plot, where on the x-axis we have the time element. Now time can be per minute, per hour, per shift, per day, per week, per month, whatever it is, but it is a time element on the x-axis. And whatever you are measuring, average call handling time, sales data, delivery time, production data, whatever, right? So that output you are plotting, and this is called time series plot. Okay, now when Shewart was studying this time series plots, he has understood a very important insight. Okay. Then he plotted a average line here. Average is called as X bar. In statistics, it is denoted by X bar. Okay. And then he plotted two more lines, one above this and one below this. Okay. Now these two lines he named as upper control limit and lower control limit. Just make a note of this. And what was the formula to derive? The formula to derive was X bar plus 3 times standard deviation, and lower control limit was X bar minus 3 times standard deviation. Now, how come this 3 standard deviation came into picture? There is a statistical study behind this. Just for your information, just you can make a note of this. Okay, I will explain this concept which I'm about to tell you in a different session, not today's session, because otherwise we will digress from the topic. Okay. What he observed that at +3 and -3 standard deviation, okay, alpha and beta error gets balanced out. What did I say? You can just make a note of this. At +3 and -3 standard deviation, alpha and beta error of the processes get balanced out. Now the immediate question is, what is alpha error? What is beta error? Okay, that's what I said. I will take another session for this, right? It is very much correlated with our hypothesis testing as well, our p-value as well. Okay, what did I say? At +3 and -3 standard deviation, alpha and beta errors get balanced out. That's why he drew the line between +3 and -3 standard deviation. And then he experimented with lot of processes, and he found that any process which is running through these two lines, upper control and lower control limit, these two lines, it is very predictable and very, very stable. So he called this as a stable process. Understand this? Okay. He named this as a stable process. Just give me a second. Okay, so what he found that at +3 and -3 standard deviation, if any process is running in this band, is very predictable. What did I say? Very predictable and stable. For example, stable meaning, predictable meaning, I always give this example of a child. There are two children. One child is unpredictable, other child is predictable. Unpredictable meaning that child does not follow any rules, regulation, does not follow any system, does not follow any timetable. Second child follows timetable, gets up at 6 o'clock, does exercises, goes to school, comes back from the school, goes to classes, then play with exactly on the same time, again studies, go to sleep on the time. It's called stable and predictable behavior. The other child does not follow these rules and regulation, which is unpredictable. Now, how do you measure that process is stable and predictable? So this formula, what Walter Shewhart has given, which is if any process flows through +3 and -3 standard deviation, is called as a stable process, got recognition from the statistician fraternity. Okay. Yes, exactly. That's what Anujji, I gave the answer. he found that at +3. So the immediate question is, why +3 and -3 only? Why not +1 and -1? Why not +4 and -4? That's what, at +3 -3, he got the balance between, I just write it down just for your information. Okay, that's what I said. I will explain this concept in some other, so balance between, now nobody will tell you this, okay? Balance between alpha error and beta error. Alpha is denoted like this and beta errors, okay? At 1 standard deviation plus minus, the balance was not there. 2 standard deviation, balance was not there. 4 standard deviation, the balance was not there. So optimum balance he found at +3 and -3 standard deviation. That's why he said upper control, lower control limits, +3 -3 standard deviation is called as a stable process. And this is called as stability test. Whether the process is stable or not. So this formula people started using, and this is called a stability test. And this graph, this chart is called as a control chart. What is that? Control chart. Okay. Now, whatever variation is there within these two limits, upper and lower control, these two limits, these are called common cause variation. Make a note of this. Common cause variation. Example, let's say our body temperature. Our body temperature also fluctuates during the day, correct? During the day also, when we wake up from the from the night, from the bed, the body temperature is different. In the afternoon, the body temperature is different. In the evening, when we are in the gym, the body temperature is different. So there is always a common variation in the body temperature. But when we have fever, our body temperature goes a little higher than our common variation. That's why we sense the fever. When we put the thermometer, right? So thermometer tells the body temperature, which is a little up. Now that is called a special cause variation. Understand this? So when we have the fever, let's say viral fever, it's a special reason. That's why the body temperature variation has gone up. That is called special cause. So most probably the data, if we see, it will go like this. And this is called special cause variation. Make a note of this. So within the band of upper and lower control, it is called common cause variation. And whatever goes up above the control limit, it's called special cause variation. Now listen to me very carefully. For special cause variation, you don't have to do a lot of things to identify the causes because it is clearly evident. Understand this? This is very important point I'm driving. Okay. For special cause variation, the causes are easily identifiable. You can immediately take action on them. But for common cause variation, it is very difficult to identify the cause. Why your body temperature is fluctuating, 0.1 degree here and there, it is very difficult to identify. And that's where the advanced tools like Six Sigma comes into picture. Six Sigma is not used to take care of special cause variation. Six Sigma is used to reduce your common cause variations. How many of you got it? Just give me yes in the chat box. Six Sigma, you don't require Six Sigma to identify special cause variation because it's clearly evident. I'll always give this another example of office arrival time. The day you come late by 1 hour, the cause is clearly evident. There was an accident on the road, or your car got broke down, or your tire got punctured. The cause is clearly evident. उसके लिए Six Sigma की आवश्यकता नहीं है. Where Six Sigma is required is the common cause variation. So Six Sigma is used to reduce the common cause variation further down. And that is where it is very, very important. It requires special efforts. It requires, cause and effect, Y-Y analysis, hypothesis, regression, DOE. All these tools are required to reduce the causes, common cause variation down. And that's where It is very, very important. Clear? So what we have covered, it is Walter Shewhart. He is the father of this. Okay. He has started a branch called Statistical Process Control, which is SPC. We call it as SPC. And further down, it is, SQC also came out of it. So statistical process control, statistical quality control, control charts. This is what Walter Shewhart started. According to Walter Shewhart's study, if a process is flowing between +3 and -3 standard deviation, it is called as a stable process, predictable process, and this is called a stability test. Okay, now, so at that point in time, people started following this. Okay, so this is a basic control chart which we are going to learn. So let me share. Okay, you can open any control. Okay, let me share this अपना regular वाला sheet itself. Okay, एक बार मिनी टैब पे करके देखते हैं इसको. एक बार हम लोग मिनी टैब पे करके देखते हैं. Just open this sheet which we use. So today we are going to learn this along with that other control charts. Okay, and then we are going to learn. There are some special tests as well. In the control chart, there are some special tests which also we can measure. Shall open this. If you have laptop, mobile, with the Minitab. Okay, the new members, especially if you don't have Minitab installed laptop in front of you, don't worry. Just observe whatever we are doing here. Okay, and once you get Minitab with you, then you can check the recording and practice yourself. Okay. Once you have opened, let me know in the chat box. Open. Done. So all the control charts basically are covered in our green belt curriculum itself. Okay. And there are majorly 7 control charts which we study. Okay, today we are going to touch upon some of them, not all of them, not required, but some of them will definitely do. Okay. Very good, very good. Done, open, very good. So it's a chocolate weight wala example which we always take. So इसका control chart निकालते हैं. Go to stat. कहां पे मिलेगा आपको control chart? In the stat, you have control chart. Here. Stat control chart. Now, because we want to make the first basic control chart, which is called as individual control chart. So we will select individual. Just follow this path. Stat control chart. Variable charts for individual. Just follow this path, please. And click on individual. Stat control chart, variable charts for individual. Just click on individual. Now this window will pop up. In the variable option, just double click on this chocolate weight wala column. Just double click on that. It will get selected. Don't do anything else. Just click on OK. That's the beauty of Minitab. Just click on OK. Everybody got this? Just give me a yes in the chat box. Very good. So only one point is just touching. You can see here. This is only one point just touching this upper control limit. Okay. Otherwise, this process is fairly stable process. Even one point crosses this. Okay. This is shown as red. Even it touches the boundary rope. It is like, in a cricket match, if we hit the ball and if the ball hits the boundary rope, that is also given as a 6, right? Similarly, this is again a special cause variation, requires investigation. All right. Otherwise, all the data points, almost 120 data points are there. 190 data points are within the control limits, and the process is fairly stable process. This is called eye chart. I stands for individual. Why individual? Because all the data points are individually plotted. That's why it is called eye chart, individual chart. Are you clear with this? Clear hai? Everybody clear with this? Just give me yes in the chat box. So you can just make a note of this stat control chart, variable chart for individual and individual. Just write down this path, and in your curriculum, the screenshots, this path, how to select, everything has been given. Screenshots also have been given. Okay, so you can practice. Plus, we have given you some sample data files as well, where you can practice this. Okay, now, so this is called individual control chart. Let me go back to my okay, so इस पे ही काम करते हैं. Let's go back to the data. Now, how do we go back to the data here? Just click over here. You can see my cursor. Okay, if you click on that, you'll come back to the data. Okay. So this is the data. So data, if you see the data properly, on the second column, we have samples. Okay. Let's try to understand this. Imagine you are a quality control person, and let's say this is a conveyor. Okay. This is the conveyor and the chocolate. So this is the bucket where all the chocolates are falling, and all the chocolates are getting produced from the process. This is the process. And the chocolates are flowing like this. And now you are standing here. And first you have taken individual samples, one samples each. Okay. Now, instead of individual, if you are taking 10 samples, let's say 10 samples like that, that is called as a subgroup sampling. What is that? Subgroup. That means instead of one sample, one chocolate, you are taking a group of chocolates. Okay. Let's say you are in a BPO. You are a quality inspector of a BPO. Instead of, let's say there are two options. One is individual data. You are taking individuals data. And now you are taking group of 10 people data. That is called subgroup. Okay. So this is called subgroup. So now when we are taking subgroup, there are two different control charts we can have. One is called as X bar R chart, and other is called as X bar S chart. If the group of samples are less than 10, we go for X bar R chart. When the group of samples are more than 10, then we go for X bar S chart, which we are going to just perform right now. Okay. What is X bar? X bar is nothing but the mean. And what is R? R stands for range. What is range? Maximum minus minimum. Okay. And X bar S matlab, X bar stands for mean, that is as it is, and S stands for standard deviation. Okay. So let me explain you again on the data. Then we will perform this. Okay. With the help of Minitab. Now, for example, here you can see they have selected 10 samples here. Can you see? This is the first 10 samples. Okay. Sample 1, meaning there are 10 chocolates they have selected. Now, there will be the average. If I take the average, there will be some X bar. So let's say X1 bar, because it's a first sample. So the average of the first sample is X1 bar. And there will be range. What is the range? Maximum. Let's say, what is the maximum value here? If you see 43.1, correct? So this one is the highest value, 43.1. And what is the lowest value? You can see 39.6. That is the lowest value. So minus, highest minus lowest is called range. So we'll call it as R1. That software will calculate. Similarly, so this is when when the data is less than 10. Sample size is less than. Now we will select both. Okay. When the sample size is more than 10, x1 bar will remain as it is. Instead of range, the software will calculate a standard deviation. What is standard deviation? For these 10 data points, software will calculate a standard deviation. And standard deviation of the sample is called as S, small s. Okay. So similarly, x2 bar and R2 will be calculated. X1 bar and S2 will be calculated for the second sample, for the third sample, for the fourth sample, for the sixth sample, etc. Are you clear? Just give me yes in chat. So there will be two graphs. One is X bar and other one is R, and X bar and S. There will be two graphs will be created. Are you clear? जब हम लोग बनाएंगे तो ज्यादा समझ में आएगा इसको. Clear है? Just give me yes in the chat box. Clear? Anybody has any doubt, please let me know. Okay. Especially the new members. Have any doubt, please let me know. What is X bar, what is S, what is R? R is range, X bar is standard deviation. Okay, the sigma basically. ठीक है? So हम लोग करके देखते हैं. Yes, I will tell you R and S का reason. R and S का reason क्या है? Why R and S differently? See, when the sample size is less, okay, you can take range as a variability. See, what we are doing here is X bar is talking about central tendency. X bar is talking about central tendency. Okay, when say, for example, when we have the data like this, there is a central tendency, the center of the data, right? And there is a spread, variation, variability, correct? So R is representing variability. And both very, very important parameters, right? Central tendency is also very important and variability is also very important, right? So when the sample size is less, you can take range as a very small indicator of the variability. But as the sample size goes beyond 10, okay, 20, 30, 50, etc., then range may not be the right indicator. In that case, standard deviation is always a stable indicator. That's why when more than 10, go for standard deviation. Less than 10, range also can be. See, you can directly go for standard deviation for all as well. But this is what the distinction has been given. Okay, clear, Girish ji? R and S का formula, R and S का reason. Yeah, very good, very good. चलो, तो करके देखते हैं. Let's go to stat, control charts. Now this is a subgroup. Remember what is subgroup? One is individual, which is one chocolate. That is individual, which we have already done. Now this time this is subgroup. Okay. So first we will select subgroup and X bar R. The first option itself is X bar R. So select that. The remaining things exactly remain same. Stat, control chart, variable chart for subgroup, X bar R. Just select that. Here, just select chocolate weight and subgroup size, just select sample. That's it. So chocolate weight का column को ऊपर select करो, नीचे subgroup size को select करो and say okay. And you will get this graph. Yes, got it, everybody? Just give me yes in the chat box. I repeat again, stat, control charts, variable chart for subgroup, X bar R. First we'll go for X bar R, then we'll see X bar S. Okay, very good. Very good. Anybody behind, please let me know, okay? So we'll wait for you. Fantastic. So here you can see the top graph is X bar chart and the bottom graph is R chart. That's what is called X bar R chart. Both charts are different. So first, let's say this point is X1 bar. This is the average of first 10 chocolates weight. Okay. Second, this is the second group's average, X2 bar, then X3 bar. x4 bar, x5 bar, etc. And it continues. Okay. Now this average is called x double bar because this is the average of averages. Every data point itself is an average, x bar. Okay. And this center line, this line is basically is average of averages. That's what it's called as x double bar. Okay. Which is 42.106. Coming back to the bottom wala graph, which is range graph. Now you can see this dot is R1, which is the range of sample 1. Highest chocolate weight minus lowest chocolate weight. It is R1, range 1. Then this is range 2. This is range 3, range 4, and so on and so forth. And the center line is the average, which is R bar, which is the average of all the ranges, which is 4.992. Okay. But again, the fundamental remains same. Nothing is going beyond control limits. That's why this process is fairly stable process. Clear, everybody? Just give me yes in the chat box. Super clear. Now try to connect with your own process where I will use these charts in my process. Okay. Whether I will use I chart, whether I will use X bar, R chart, X bar, S chart, etc. Okay. Now, let's go for X bar S chart. The same procedure, go to stat, control chart, subgroup, just below X bar R, there is X bar S, exactly the same procedure. Okay. Previous, there was a special cause because it was individually plotted. Okay. But in the subgroup sample, that has been, there is no special cause. And even if you see in the previous case, the point was also in the just in the boundary line. Okay, correct. Yeah. So what does it indicate? So within sample the variation is less. Okay, there is a concept of within and overall. You must have heard this concept, yes or no? Within variation and overall variation, yes or no? What is within? So within sample, correct. So within sample variation is less. Overall, a little bit of more variation you can find out. That is what you can conclude this. Okay. So fairly this procedure is, you can say this is stable. Now this depends which chart you are using. This depends on your sampling strategy. If you are taking individual samples, go for I chart. If you are taking group of samples, go for X bar R and X bar S. So decision of your chart depends on your current sampling strategy. All right. That will define. If you're taking group of this, then you go for this X bar R and X bar S. Now let's go for the same X bar S chart. Select X bar S. The same procedure will be followed. Select chocolate weight. Subgroup size is sample. Say OK. And similar kind of chart has been selected. X bar chart exactly remains same. Let me just minimize it so that you can easily find it out. How do you minimize it? You can see here there is a minimize button. So you can minimize the graph like this. Okay. So this is the first first graph has been minimized. Let me see the second graph as well. No. Okay. So let me go for the second graph as well. So this is the X bar S chart. इसको मैं यहाँ से drag भी कर सकता हूँ minimize करने के, ठीक है? And that's how we can bring these two graphs together. Okay. So you can see here X bar R chart on the left hand side, X bar S chart. So X bar and X bar absolutely same. ये सेम ही है, इसमें कोई फर्क नहीं है. X bar. Okay. Only difference is instead of range, here there is range. Here we are actually checking standard deviation. That's the only difference. But again, both the graphs are actually showing the similar kind of stability. Clear? Got it? Just give me yes in the chat box. Everyone got this? Just give me yes. Very good. Very good. Can you just close that, please? Super. Okay, now listen to me very carefully and answer this question. Okay, what if? So see, now it depends on your what you can say your um, what you can say your data. Okay, so behavior of the data will define the behavior of your chart. All right. Now here let me ask you one question. What if the data point goes out of control limit? Let's say if the data point is like this, what will you do? This is again special cause variation, yes or no? What will you do? Type in the chat box. If a data point goes beyond control limit, what will you do? Eliminate out the layer, okay? What is the action you will take? Eliminate the event. Ah, very good. Find RCA, Ravindraji. Absolutely. So whenever it goes beyond control limit, immediately we need to identify that special cause. That's what is called special cause variation. And it is very easily identifiable. Are you understanding? So immediately take action and bring the process within the control limits. That's what we need to do. Clear, everybody? Yes? Yes or no? Yes? Now, what if it goes below this lower control limit? Then what do we do? If it goes above upper control limit, we have to take. What about below lower control limit? What do we do? Everybody think about it. Do we have to investigate? Yeah, that means the mean has shifted. See, understand this. When it goes, now try to understand this, what I'm talking about here. When the process has shifted above control limit, that means there is a potential of mean shift getting shifted. The average process getting shifted. And understand this, how dangerous that is. If the process is shifting on one side, there is a probability of making rejections and defects. Yes or no? It's an indication. Similarly, if the process is shifting on this side, the same thing can happen on the lower specification limit. Yes or no? It can create rejections and defect. So both this direction, whether the process shifts on the upper side or lower side, we have to immediately investigate and take action to bring the process in the center. Everybody clear? Just give me C for clear in the chat box. C for clear. ये clear है? Okay, whether it goes up, whether it goes down, we have to investigate and take immediate action to bring the process in the center. Now let's come back to the range chart. Now, when the range is going above control limit, that means what? The distance, the difference between highest and the lowest chocolate weight is becoming greater. What does it indicate? Is becoming greater. That means the variation has increased. More variation. So whenever the data, whenever my process goes above control limit, upper control limit, it's an indication that the variation has increased. See, X bar meaning the mean is shifting. The average is shifting. Are you understanding? See, let me draw this. Okay, let me draw this. X bar shift कैसे होता है? If this is my X bar, now my process is shifting like this. So earlier it was here, now it is shifting here. It is called X bar shift, ये वाला graph. Okay, and how the variation shifts? Let's say this is my current variation. Now this is my next variation. Are you understanding? The variation has increased. How many of you got it? Just give me yes in the chat box. The first graph is showing the mean shift. Second graph is showing the variation increase. Yes. How many of you can visualize this? Second graph is a range chart, which is an indication of variation. Okay. Now, when the range going above upper control, that means the variation has increased. What do we do then? What is the action do we take? What do we do? Type in the chat box. See, this is what we need to learn. Exactly the same thing applies there. Investigate, find out the cause, take action. Same thing, right? Now the range goes below a lower control limit. What do we do? For example, here, let's say the data goes below lower control limit. What do we do? Type in the chat box. So the range has gone up, variation has gone up, take immediate action. So let's say range has gone below lower control limit. It has lowered down. What do we do then? Similar action, investigate, find out the root cause. We need to investigate, but we should not take any corrective preventive action. Because when the range will go down, when the variation will go down. So understand this. Let's say, just try to, this is very interesting. Huh? This is what is the bulb on moments. Okay. Look at this. Let's say my process is, the original process is this. This is my original process. Okay. When my range increases, the process will look like this. More variation. When my range decreases, my process will look like this. Yes or no? Very, very close. Very much close to each other. Now, that's where it can go below lower control limit as well. Right? So here you can see, na? रेंज का इंडिकेटर क्या है? 0. यहाँ पे देखिए, कहाँ पे? यहाँ पे you can see here 0 1 2 4. When it comes to very close to 0, that is the best thing, right? In that case you should investigate why, what has brought this best result. वो हमें पता लगना चाहिए, इन्वेस्टिगेशन होना चाहिए. Okay, but don't take any action, otherwise you will create chaos in the process. If the variation is reducing, that's the best thing you can do for the process, right? So don't take any action. That means to conclude X bar R and X bar S chart, if in the X bar chart, if it is going up or down below the control limits, take action. In the range chart below this here, if it goes above upper control limit, take action. If it goes below control limit, don't take any action. Are you clear with this? Just give me yes in the chat box. If it goes below control limit, lower control limits, it is an indication that the variation is reducing, which is the best thing which we are looking for, right? Same goes with X bar S chart. Whenever standard deviation goes down, don't take any action. Clear? Super clear hai? Very good, very good. Super. Now, let me go back to my whiteboard. Okay. And so what we have done, whenever we have continuous data, we have two types of data, continuous data and discrete data, right? Correct? Yes or no? Discrete data, correct? So whenever we have continuous data, we go for individual chart, X bar R chart and X bar S chart. Okay. Whenever discrete data comes, we have to follow this table. Okay. If R goes down, investigation is still important. Yes. Because we should know what has brought the best in the process, right? किस वजह से हमें अच्छे मार्क्स मिले, किस वजह से मैं प्रोसेस हैज स्टेबलाइज्ड. ओके, दैट वी शुड इन्वेस्टिगेट, बट डोंट टेक एनी एक्शन, चलने दो उसको. दैट्स व्हाट वी नीड टू मेक श्योर. ओके, yes, very good, very good, super. So when it comes to discrete data, just make a table like this just for your information. Are you guys enjoying this discussion? Just give me yes in the chat box. Anybody who is not enjoying or not learning something new, or कुछ भी समझ में नहीं आ रहा है, ऐसा कोई है? Just give me yes. It is absolutely okay, because especially the new people, okay, it might be a little difficult. Maybe if it is your first live session and now this is very difficult to digest. Okay, what is continuous data? The data which is measured on a continuous scale, like height, weight, the speed, temperature, pressure, and which can be expressed in decimals. It is called continuous data. On the other side, discrete data is the data which is counted and not measured. Counted meaning how many parts are defective, how many defects in one part. All these are counted, 1, 2, 3, 4, 5, and it cannot be cannot be expressed. Oh yes, Ravindraji, thank you for reminding me. Okay, so at the end of the session, when I will just brief them, we will welcome them. Okay, thank you for. I just started the session. Thanks for reminding me the ritual. Okay, we welcome the new members, but anyways, we'll do that. Okay, let's continue this and we'll welcome them. Okay, so in the defect column, there is constant sample size and there is another option which is variable sample size. Okay, just make a note of this. I'll explain you quickly. Control charts के ही अलग-अलग types है. So you can just make a table like this. Okay, just make a table like this. Now, this is N, NP. Now try to understand this. If you draw a table like this, when it comes to discrete data or a count data, like number of pieces rejected, it is a discrete data. It is not, yes, continuous data is measured on a continuous scale. Height, weights, length, width, pressure, temperature, speed. All these are continuous data. Discrete data is how many people in the room. 10 people in the room. It's called discrete data because we count the number of people. How many parts rejected? Discrete data. Okay. Another example, if you are in the BPO call center, how many calls received is a discrete data. Average call, time, average call time is a continuous data. Are you understanding? Let's say 4.5 minutes per call. It's a continuous data because that can be measured. Okay. And discrete data, how many number of calls? 100 calls received in a shift. That is called discrete data. Everybody's clear about discrete and continuous differentiation? Just give me yes quickly. Differentiation clear hai? Yes, very good, very good. So here we get, there are 4 different types of discrete chart. The first one, let's try to understand. First, try to understand the difference between defect and defective. Just try to understand the difference. What is defect and what is defective? Okay. One product, complete product, is called as a defective unit. And within that defective unit, there could be multiple defects. Okay. Example. Let's take your yellow belt exam. Okay. In your yellow belt exam sheet, there were 15 questions. Okay, YB exam. 15 MCQs were there, multiple choice questions. Okay. Now, this one exam sheet is called as a unit. Okay. If you score, understand this, if you score 70%. Let's talk about, let's take a 10 MCQs. Let's make it very simple. Let's take there are 10 questions. Okay. If you give 7 right answers, that means you clear the examination. It is not defective. Let's say out of 100, 5 students failed to score 7 right answers. That means it is called 5 defective out of 100. Are you clear? This is called defective. So one exam question paper is 1 unit. Out of 100 units, 5 students failed. So 5 defective papers. Are you clear? Just give me yes in the chat box. Are you clear with this? Just give me yes. Clear? Now, in one form, in one examination form, there are 10 questions. So then 10 probable defects are there. Are you understanding? Now, instead of how many defective forms are there, if I start counting number of defects, that means wrong answer. Defects meaning wrong answers in this case. Okay. If I count the number of defects, that is called, then I will use this column, defect column. If I am using the number of defectives forms, then I will use this column. Are you clear? Defect and defective. So defective is a complete unit and defect is in that complete unit. How many number of defects are there? Are you clear? Just give me yes. So what are we collecting the data that will define what chart to be used? Are you clear with this? Just give me yes. Very good. Super, super. Now, there is another variable which is called constant sample size and variable sample. What is constant sample size? For example, every yellow belt exam, every, let's say Sunday, there are 1,000 people give the exam. Okay, let's say 1,000 people, it's a fixed sample size. Then in that case, we will use the first row. Okay, and every Sunday, let's say one day there are 1,000 people, another day there are 900 people, then 800 people, then it's called variable sample size. Are you understanding? If you have fixed sample size, then go for the first row. If you have variable sample size, you go for the second row. Clear? So I've given you a very practical example which you guys have been through just very recently. Clear with this? Just give me yes in the chat box. So in our Sunday sessions, generally there are 800, 500, 600, 1,000 people attend. Correct? So it depends on, is the sample size constant and is the sample size variable. Here, so this is the, so you can always refer to this graph. So let's take 1 or 2 sample. Okay. Let's take one example of constant sample का एक example लेते हैं C chart का और एक variable sample का लेते हैं just for your understanding. Okay. Now let me share a file with you. ठीक है, पहले एक मैं फाइल शेयर करता हूं आपके साथ. एक C chart का मैं फाइल शेयर करता हूं. We'll start with C chart. फाइल मैंने दिया हुआ है. Just open that file, please. I will also open along with you. And then we will go for one, maybe U chart or P chart. Okay, एक constant और एक variable का हम लोग use करेंगे. ठीक है? C chart का open करिएगा. Once it is done, let me know. When do we use C chart? When we are counting defects with a constant sample size. Okay. Yeah. Once you open it, let me know. Now the same example has been taken. Let's say there is an examiner who has taken this data. For the first question paper, for the first student, there are 4 errors or 4 defects the first student has made. The second student has made 2 defects. Third student has made 1 defect, 1 wrong answer. Fourth student has made again 1 wrong answer. Fifth student, 4 wrong answers. So he has just made a list of how many errors those students have committed. Okay. Now in this, the number of questions are fixed. That's why the sample size is fixed. And how many number of defects they have made, that's what it's called C chart. So let's go for C chart. How do we go for C chart here? go to stat, control charts. So the same option available. Here, you will go for attribute. Now, discrete is also called as attribute chart, right? So select attribute chart and select C chart. You can see, follow this path, stat, control chart, attribute chart, C chart. Once you click on this, now in the variable, you need to select errors. Okay, just select errors and click on OK. And you will get this graph. Okay, now this graph shows. Now, the first question is, what is this? Number of errors are plotted. Just try to understand this. Just pure number of errors are plotted. First person has 4 errors. Then second person has 2 errors. Third and fourth has got 1 error. Again, fourth and fifth has 4 errors, etc. So every person error. And then this is C bar, which is the average, which is 3.91. So everybody has made almost 3.94 errors. Okay. And control limits have been. Now you cannot have control limit going below 0 because you cannot have negative errors, right? Either you will make 1 error or 0 errors. Maximum will be 0 errors, right? So the control limits are stopped at 0. Upper control limit. Now, here, the formula of calculating control limits are different. I will give you the formula as well. Okay. Again, you need not to remember the formula, by heart the formula, etc. Software is there. You just have to select the right chart for you. Okay. Here you can see there are 3 points going outside of the control limit. That's what the process is not stable. Clear? This is called a C chart. This is a discrete chart. Okay. Just one example I'm giving. Okay. Similarly, let me share with you another file of, have you got it? Just give me yes in the chat box. एक यूज करेंगे पी चार्ट का, पी चार्ट विच इज अ वेरिएबल चार्ट. आ गया सबको? वेरिएबल. ओके, एक बार पी चार्ट यूज करते हैं. ओपन दिस फाइल विच हैज बीन गिवन टू यू, पी चार्ट वाला. Again, the formula for the discrete chart will be a little different than our x bar plus and minus 3 standard deviation. Okay, थोड़ा formula में difference है, but doesn't matter. We don't have to remember the formula. I'll show you the formula as well for your reference. Okay. Meanwhile, as you are opening the file, let me, yeah, let me share with you what is the data. Okay. Now the data is, in this case, the data is, when do we use P chart? When we have defective meaning how many students are failed. So one sheet, right? How many students are failed? Now, let's say first classroom, there are 50 students, out of which nobody failed. Okay. Second classroom, again 50 students, nobody failed. Third classroom, there are 60 students, 1 student failed. So here there are variable sample size, okay? 50, 60, 70, 80, etc. And there are, there are the failed students numbers, okay? So we'll go for P chart here. Go to stat, control chart, attribute chart, and P chart. Okay. Once you select P chart, here double click on pass and fail, which is the variable which you want to plot. And subgroup size में आपको select करना है sample size and not serial number. Okay, sample size. Just double click on sample size and click on OK. I repeat again: stat, control charts, attribute chart, P chart. In the variable, select pass and fail. In subgroup, select sample size and say OK. And you will get this graph. Now, the interesting part is that this control limits are zigzag type control limits. Why? Because every control limits for every data point is separately calculated. Okay. Because the sample size is different now. Understand this. One failure out of 50 students is a different ratio than one failure out of 60 and one failure out of 80. Are you understanding? So you cannot compare. So every failure rate is different actually because the denominator is different. That's why every time the calculation of the control limits are differently done. Okay, that's why it looks like zigzag, but only thing is that any data point going beyond or above control limit, that is what we need to observe. That's it. Clear, everybody? Just give me yes in the chat box. These are called discrete control charts. Clear, Ham? Very good, very good. So I am going to share with you a PowerPoint presentation, a small presentation. Okay. Yeah, Girishi, what do you want me to repeat? Tell me. Let me share with you a presentation. Do you want me entire thing to be repeated? हाँ, last time मैं repeat करता हूँ. Okay, so I'll be sharing this document with you. This is the same thing. Okay, how do you select the which control chart to be used when? Okay, so this is a tree diagram for your reference. I will share with you. So here you can see I chart, X bar R, X bar S chart, C chart, U chart, P chart, NP chart. All the charts are given in which what you can say scenario, which chart to be used. ये chart आपको दिखाएगा. Okay. Now these are the control limits calculation. Again, do we have to remember this? The answer is absolutely no. So we have the formula already inbuilt in the algorithm of Minitab. It calculates it. What we need to check is whether the process is unstable or stable, whether the data is going beyond control limits or not. That is something we need to check. So the formulas has been given. Okay. In the formula, you can see there are few values. Okay. For example, you can see here X bar का अगर मुझे कंट्रोल लिमिट चेक करना है X bar R वाला. Okay. So the formula is X bar plus A2R and X bar minus A2R. Similarly, you can see R and S के formula में D4R, D3R. So what is this A4, A2, D3, D4? So in the next slide, it has been given to you. Okay. Sample size, according to sample size, this A2, D3, D4 are selected. Okay. Yes. Correct. There is no, in few cases it is there. For example, P for proportionate control chart, proportionate defective control chart. NP is non-proportionate defective control chart. इस प्रकार से है. बाकी C और U के लिए कुछ expansion नहीं. Okay. Now coming back to this. So these are the constant values, okay, which has been provided. Again, you don't have to remember these things. I've just given you for your reference. Okay. So I will just be giving this document to you. Just refer it for your knowledge. Keep it with you. Download this document and keep it with you. Okay. This document I will give you. All right. Now I will just explain you for Girish ji once again the last wala जो हमारा graph था, which is P chart. Okay. So P chart हम लोग कब use करते हैं? When we have defective data. Okay, and we have non-constant sample, which is variable sample size. Okay, एक classroom में 50 बच्चे हैं, दूसरे classroom में 60 बच्चे हैं, 70 बच्चे, etc. So that's where we use P chart. Now here, according to the sample size, the software will calculate. For example, let's talk about this first data point. So in the first data, there is zero failure. Nobody has failed. Okay, so 0 divided by 50 students becomes 0. Okay. Second data point is 0 out of 60. Again, the number is 0. So you can see the ratio is 0. Okay. What is the third one? Third data point is, let's say, let's go back to the data set once again. Open the data set here. Third one is 1 out of 60. So what is 1 out of 60? 1 divided by 60. What is the value of this? 1 divided by 60. If you see here, you can see this data point. Okay. So this is a ratio. It must be 0.0166. You can see here. If you put the cursor, it shows the proportion. 1 divided by 60 is 0.0166. So the software has plotted this ratio. Again, the same, again, the fifth one is 0, sixth one is 0, seventh one is this, eighth one is similarly, all the ratios have been plotted. Then the average ratio has been calculated, P bar, which is 0.008. Upper and lower control limits have been found out according to the formula which I showed you. And then it is plotted. And upper lower control limits are calculated for each data point separately because the sample size is not constant, right? We just have to check whether the data, any data point going beyond control limit, that's it. Are you understanding? Again, the same funda remains here. Okay, if it is touching zero, do we have to take anything? No, right? It's a good thing. Zero failure is a good thing, right? So don't take any action. Okay, if it is going above control limit, then you have to take the action. Clear, everybody? Just give me yes. Super clear है ये? वेरी गुड, वेरी गुड, वेरी गुड. अच्छा, एक और भी एक इसमें से एक एडवांस टूल मैं आपको दिखाता हूं. ओके, लेट्स गो बैक टू अवर फर्स्ट ग्राफ. ओके, फर्स्ट ग्राफ पे जाते हैं एक बार फिर से. ऑलराइट, कैन यू ओपन दिस फर्स्ट वाला ग्राफ जो चॉकलेट वेट वाला था, उसके ऊपर जाते हैं. Once you open that, let me know. Let me see if we have that. Okay. Yeah, once you open that, let me know. Okay. हाँ, ये वाला चॉकलेट वेट. ठीक है, ओपन नाउ. इसमें और एक मैं स्टेप्स बताता हूं, विच इज नाउ +3 -3 standard deviation, which we have already seen. If anything goes beyond a +3 -3 standard deviation is actually considered as out of control, right? Unstable process. Just quickly, let me just cover something else as well. Let's find out stat control chart, variable chart for individual. Just go back again to the basics. Okay, select chocolate weight. But before you enter OK, just go to eye chart option here. Go to eye chart option. And there is something called test here. Okay, I repeat again. Open this file. Go to stat, control chart, variable chart for individual and individual. Okay. Once you click that, select chocolate weight, but don't click on OK. Just do one small setting. Go to eye chart option and go to test. Okay, parameter, estimate, limit, and there is something called the fourth option is test. Just click on test. You will see lot of options over there. Okay, try to understand this. You will see lot of options over there. Just drop down, just click on this drop down menu and select perform all test for special causes. Perform all test for special causes. Click on that. And don't do anything else. Okay. I repeat again. Once you select chocolate weight, don't click on OK. Go to eye chart option. Go to test. In the test, select drop down. And the first option is perform all test. Click on that and click on OK. Now you click on OK. Very good. Now, everybody got this? Now here, you would have seen some red dots getting popped up here. Okay, some red dots. Now, what are these red dots? Just try to understand this, okay? Now, what is this upper control limit? This is +3 sigma level, okay? What is lower control limit? This is minus 3 sigma level from the mean, right? Now let me draw some imaginary lines here. This is plus 1 sigma. Okay. Just try to understand this. This is plus 2 sigma. And the third line is plus 3 sigma. Similarly, below the X bar, this is minus 1 standard deviation. This is minus 2 standard deviation. And then the lower control is minus 3 standard deviation. What I've done, I have just given 1 standard deviation ke lines. Okay. Now, yes, everybody with me till now, just give me yes in the chat box. यहाँ तक सब कुछ मेरे साथ है, everybody. Okay. Now here you can see there are 3 different types of dots. Here is one red dot showing the 1 number. Second red dot here showing the 5 number. And there are few dots which are showing 6 numbers. Okay. 1, 5 and 6. Now what does it mean? Just try to understand it. Okay. Just try to understand first. What does it mean? Let's go back here. Go back to eye chart option. Go back to eye chart option. Test. Okay. So here you can see test number 1. Observe here. This is the advanced usage of the control charts. This is test number 1. This is test number 5. Okay. 1, 2, 3, 4 and 5. This is test number 5. And this is test number 6. Okay. Let's try to understand this. Test number 1 is what? 1 data point above 3 standard deviation. You can see K. K is equal to 3. 1 standard deviation about 1 point above 3 standard deviation from the center line. It's called test 1 failed. That's why this data point you can see here. Failed. That's why software is highlighting it has gone out of control limit. But within the common cause variation, there are few patterns. What is pattern? Pattern meaning there is an indication of the process before it goes out of the control limit. The software is giving us the signal. Please give the focus because the process is shifting. Okay. Now, for example, look and see here. Fifth test is this. K out of K plus 1 point. Okay. More than 2 standard deviation. Now, K out of K plus 1 point matlab, here you have by default there is 2. That means K out of K plus 1 point. That means 2 out of 2 plus 1 meaning 3. That means 2 out of 3 points above 2 standard deviation. Now you can see here. You can see here. This, this data point. 2 standard deviation from the center line. यही है क्या failed? Okay. 1, 2, 3, 4 and 5. Okay, ये वाला data point है. Sorry, ये वाला. So we are talking about this data point. Okay. ये data point क्या बोल रहा है कि एक data point out of 3 has gone, above 2 standard. Can you see this line? ये data 2 standard deviation से आगे चला गया है. What does it indicate? If you don't fix this point, this process, it might go outside. That's why it is indicating process point number 5. This is an indicator. See, this is the process not failed, but it is about to fail. Are you understanding? Yes. So it is an indication. Similarly, you can see the test number 6. Okay. What it is showing, the K value is 4. Now these are by default. Okay. You don't have to change these numbers. K out of K plus 1. That means 4 out of 5 points are going above 1 standard deviation. You can see here this bunch. Okay. 4 out of 5 points. You can see 1, 2, 3, 4, 5, 6. So out of 6 points, 3 to 4 points are going above 1, So a bunch of the data points, you can see here a bunch of the group of data points going above 1 standard deviation. That means the process is about to shift on the upper side. So it is indicating us. So these are the tests. These are different, 8 different types of tests are given. If you click on them, okay, they will indicate the smaller changes in the common cause variation as well. Okay, this is an advanced tool in the control limits, control charts. Are you clear? Just give me yes in the chat box. These are called different tests, which also we can activate. Okay. So this is all about control charts. Most of the things are given in the green belt level. These kinds of advanced tools are used in the black belt level. Okay. Yes. So any question about it, please let me know. Now we will welcome the new members, by the way. In the anybody displayed in the session window as well. Yes, very good, very good. So anybody new in the room right now, just type me in the chat box. Any person who is attending the session first time today, just type me in the session, me in the chat box. Anybody in the room? I just missed this ritual in the beginning. Okay. Yeah. Anybody? I think nobody, is it? Okay. That's surprising. All right. So new members, team, can you just check why the new members have not, maybe they may not have understood, how to connect the session, etc. Even though we send them the gentle reminder, again, today being Monday, it is quite possible, it is not possible for them to join the live session. Okay, possible. Anyways, anybody who does not have the login ID, password, etc., you can connect on our, you can connect on our WhatsApp number, mentors number. Okay. What is the relationship between the control 3 sigma and a sigma level? Very good. Sigma level is, so sigma level is the process capability number. Okay. 2 sigma, 3 sigma, 4 sigma, right? It's a process capability number. As your variation goes down, right? Your sigma level, you go to the 2 sigma, 3 sigma, 4 sigma, 5 sigma level. Okay. And the control limit is that standard, that talks about the standard deviation. Understand this? Okay. So that's the only difference between, as you reduce your sigma, okay, your process capability number goes up. So our objective is to reduce the standard deviation, which is sigma. And while reducing the standard deviation, we go to 2 sigma, 3 sigma, 4 sigma, 5 sigma, etc. So our objective is to reduce standard deviation and, increase our sigma level. That's how it is. Ideally, LCL should be 0 for all the charts. Not really, not really. It depends on the data. It depends on the data. Okay. But for the discrete chart, discrete data, okay, LCL, most of the times LCL will be 0 for the discrete charts. Okay. Most of the times, but not necessarily. Understand this. Okay. Because it's a ratio, right? Ratio cannot be negative. So you cannot go below 0. Yes. So it's like one rejection out of 100. So you maximum you can have 0 rejection. You cannot have -1 rejection, right? That's why it is. Yeah. Super. So आज थोड़ा सा extension हो गया 20 minutes का, but I think it was fruitful. I covered most of the concepts of control chart today. Thank you very much. We'll connect again, with the masterclass archive में. So in these my courses, no, you will find masterclass, live masterclass archive. In that, just scroll down. You will find the latest, what you can say, the topic. Let me show you if I can. Let me show you the masterclass archive quickly. So in your my courses itself, there is a folder called masterclass archive. And if you go to masterclass archive, just, Lean Six Sigma Live Masterclass Archive is the full name of it. Okay. Lean Six Sigma Live Masterclass Archive. Let me just open it for you quickly. Once you log in, go to my courses, go to Lean Six Sigma Live Masterclass Archive. हाँ, मैं just open करके आपको एक बार दिखा देता हूँ, just for your reference. Okay, here we go. So this is Lean Six Sigma Live Masterclass Archive. 389 lessons, almost 400 live lessons. Every lesson is 1 hour, 1 hour 30 minutes. Okay, so it is a huge. Okay, found it? Very good, very good. So scroll down करना है आपको at the bottom of it. Okay, you can see the bottom में जाएंगे तो So this was the last one, which was Minitab Basic, जो हम लोगों ने last Saturday को किया था, 22nd of November. Okay, just click on start. You will find that. All right. Now, all the people just give these fantastic reviews. Okay, अच्छे अच्छे reviews दे दीजिए इसको. हम लोग अपने CSSC के वेबसाइट पे भी डालेंगे reviews को. Okay, यहाँ पे देखिए लोगों ने बहुत सारे अच्छे अच्छे reviews दिए हैं. You can also add your reviews if you found this efforts worth. Okay. Archive stucking while watching at 1.5x. Okay, so if it is getting stuck now, it is about the bandwidth of your internet. Okay, it can go up to 2x. 2x तक जा सकता है. तो आपका इंटरनेट का बैंडविड्थ नहीं होगा ना, तो वो स्टक हो जाएगा. So it depends on your see, and there is a there is a, what you can say, internal mechanism. It reduces the what you can say, the HD. So high definition का वो जो थोड़ा सा low definition कर देता है, automatically कर देता है. Okay, so it happens automatically. But again, you have to have at least 50 Mbps, 100 Mbps वाला bandwidth just to increase that to 2x, etc. Okay, that will be better. Okay, yeah. All right, guys, thank you very much for joining. We'll connect again with a new topic in the upcoming class. Thank you very much. Take care. Keep learning, keep growing. This is Dinesh Patil.